Hello there, welcome to another lesson video. In this particular lesson, we are going to be concluding on vectors, and we will be taking a look at the relationship between coordinates or the coordinate points and vectors. How we can derive vectors from coordinate points on the Cartesian plane or as represented on the grid. And in the course of this particular lesson, we will also be talking about position vectors and then column vectors, which we have earlier looked at in a previous video. A very quick look at the difference between coordinates and vectors. Coordinates shows the location of a point on a grid. Coordinates show the location of a point on a grid. For example, you can see the point A. Its location is shown by 4, 6, which shows the x coordinate and the y coordinate, 4 for the x coordinate and 6 for the y coordinate. This is describing how we can locate point A on the grid. Point C can be located on the grid by 6, 3. 6 represents the x coordinate and 3 is the y coordinate. But the vector actually shows the change in the location of the points on this entire grid. We have referred to column vectors representation earlier as such that can be represented with a small single letter or two uppercase letters. The two uppercase letters shows the start point and the end point of the directed line segments by which we represent the vector. For example, we can talk about the vector AB. The vector AB is the vector that is determined by the start point A and then the end point B, making the arrow to point in the B direction. So in the course of this lesson, we will be having to draw out vectors in this manner from simple coordinate points that are represented on the coordinate grid. Now, we have also talked about, it's important for us to take note of this, that the point O, where the y-axis and the x-axis meet, is the origin. So if we have that as the origin, we can always refer to what we call position vectors as such vectors whose beginning is from the origin. We can always refer to position vectors as vectors whose start point is at the origin. A position vector starts at the origin, so we can refer to this vector here represented by this directed line segment as the vector OA. And we can also refer to this directed line segment here as the vector OB. But take note of the fact that we have a point A and we have a point B on the coordinate grid. This point is 3, 7, and this point is 8, 4. It is important for us to note that if we have coordinate points represented on the grid, then we can easily transform the coordinate point to what we call position vectors. I'll come again. We can easily transform coordinate points to the kind of vectors we call position vectors. If I have a point A on the grid as 3, 7, then the position vector OA means the vector whose start point is at the origin O and the end point is A, as you can see we're represented here. So if the case of the coordinate of point A is 3, 7, then the position vector OA simply will be 3, 7, the column vector 3, 7, the column vector 3, 7. If I have a point or a coordinate point B on the grid or on the Cartesian plane as 8, 4, then the position vector of the point B, the position vector of point B, which will be read as vector OB, that will be represented in this column vector form as 8, 4. You can see it is easy for us to change what a coordinate point is to a vector. And when we change that to a vector, we'll be easily writing that as a position vector. But we'll go beyond that in this particular lesson because we'll have to also write things like vector AB. In the case where we have to write vector AB, it's not just going to be as straight as we have talked about for position vectors. Now let us take a look at this example. Given the points A, 3, 2, and the point B, -2, 1, find the position vectors of A and B. In finding the position vector of A and B, remember if the point A is given, then the position vector is going to be vector OA, and that will be written as the column vector 3, 2. In the same way, if the point B is given as coordinates -2, 1, then the position vector of B can be written as vector OB. The position vector of B can be written as vector OB, and that is -2, 1 in the column vector form. Now, if I talk about the position vector of the point A, I'm talking about the vector OA, which is represented there as the directed line segment from O, my origin O here, this point, to the point A. So the point A is my terminal point, and my starting point or my origin here will be the origin here will be my starting point. In the same way, the vector OC stands for the position vector that represents the coordinate point C, which is 6, 3. Now, if I were to look for the vector AC, the vector AC, you would agree with me, from this representation will be vector AO plus OC. Of course, the O and the O strikes out, and then we have AC. Now, the vector AO is not given. What we have is the vector OA. The vector OA is the position vector of the point A. The vector OC is the position vector of the point C, or of the coordinate point C. OA is given, OC is given. What I mean is that the vector OA can easily be gotten directly from the coordinate point of A, and the vector OC can be directly gotten from the coordinate point C. But I don't have the vector AO. Of course, in our earlier lessons, you recall that vector AO is the reverse of vector OA. So that vector AC is minus OA plus OC. Minus OA plus OC. Now, since I know OA, then I'll just attach a minus sign to OA. That will give me the same thing as the vector AO. If I rewrite this, I will have OC minus OA, OC minus OA. Now take note of this. The OC is representing the vector for the coordinate of point C here, and the vector OA is presenting the vector that stands for the coordinate point of A. Take note of the C leading and the A behind. Take note of the C leading and the A behind, so that we have OC minus OA in finding vector AC. So my vector AC would definitely be 6, 3 column vector minus 4, 6 column vector for OA. And then AC becomes the column vector 2 minus 3. Take note that the vector AC simply could have been gotten without the first three steps that we have written here. If we have known the point A as a coordinate 4, 6 and the point B with coordinate 6, 3, 6, 3, then I can easily find vector AC by saying the vector representing the point C, which is 6, 3, minus the vector representing the point A, which is 4, 6. So the question could have come anyway in this manner. Given the coordinate points A 4, 6 and C 6, 3, find the vector AC. So if I am given coordinate points for A and C and I'm to find the vector AC, it's as simple as saying that AC is the vector representing the point C, which is 6, 3 in column vector form, minus 4, 6, which represents the point A, which is the vector or the position vector that represents the point A. So I didn't need to really work out those earlier three steps so that my answer becomes the vector AC 2 minus 3 in column form. If the point P has coordinate 7, 13 and point Q has coordinate 9, 6, find the vector PQ. You would agree again that the vector PQ is simply going to be the vector PO plus the vector OQ. In the same way, we know vector OQ. How do I know that? Because vector OQ will stand as a position vector that represents the coordinate of Q, while the vector OP will stand as the vector that represents the point, it will stand as the position vector that represents the point P, and the point P is 7, 13. So the vector OP can easily be gotten from that, but now I have vector PO. Of course, vector PO is not given, but I can always get that from vector OP. So vector OP, vector PO will become minus OP, because minus OP is exactly the same thing as PO. That's the reverse vector. If I rearrange this, I will have PQ as OQ minus OP. And OQ is the vector or the position vector that represents the coordinate of the point Q, while OP is the vector or the position vector that represents the coordinates of the point P. Take note again, Q is leading and P is behind. So if I'm finding the vector PQ from the coordinates of P and Q, that will be the vector that represents Q, 9, 6 minus 7, 13. 7, 13 is the vector or the position vector that represents the point P. And simply, that calculates as 2 minus 7. So let's go again in the same way, the same question. So I could have avoided those initial steps and gone this way directly, that the vector PQ is equal to the coordinate for Q as a vector minus the coordinate of P as a vector. So that would be 9, 6, because Q is leading, minus 7, 13. P is behind. So that gives us the same answer as 2 minus 7 in column form. Now let's take some examples higher than what we just did right now. We have, suppose that AB is 3, a column vector 3, 5, and AC is a column vector 2, minus 3. If the point A has coordinates 4, 6, then find the coordinates of B and C. Find the coordinates of B and C. The vector AB should be written as AO plus OB. I'm sure you would agree with that. We're first of all going to find the vector, the coordinates of point B. Now take note that we are given the coordinate of point A. So our solution goes thus: AB is OB minus OA, OB presenting the point B minus OA presenting the point A. This is a vector representing the point B. This is the position vector representing the point A. So A, B is 3, column vector 3, 5. My OB, I do not know the coordinate of the point B. Therefore, I cannot write the position vector of the point B. So I'm going to write the position vector of the point B, which is OB, as XY, column vector XY. Meanwhile, the position vector for the point A, which is OA, is 4, 6. And how do I know that? I am given the coordinate of A. Coordinate of A is 4, 6. So the position vector of A will be column vector 4, 6. So if I move this to the other side, I'm going to have my XY as 3 plus 4 and 5 plus 6 in the column form, and then my XY will be 8, 11, column vector 8, 11. Of course, that will stand as my position vector OB. If I have the position vector OB, I can easily write the coordinate of the point B. Remember, we talked about that in the very beginning of the lesson, so that the coordinates of the point B is 8, 11. 8, 11. So our point B here has coordinates 8, 11. Now, in finding or looking for the coordinate of C, we follow the same step. We are given the vector AC. The vector AC will definitely be AO plus OC. AO plus OC. But we said that having established the various steps explained, there is no need to go through all those. So we know that it is simply going to be the leading letter here, the position vector of the leading letter here, minus the position vector of the letter behind. So that would be OC minus OA. So my AC is 2, column vector 2 minus 3. And my OC is what I am looking for. So that would be X, Y, Y, sorry. Then my OA is 4, 6 once again. If I simplify this, that gives the vector 2 minus 3 plus 4, 6. And the vector XY gives me 6, 3. And that is my column vector that represents OC. So my position vector OC is 6, 3. Therefore, the coordinates of the point C is 6, 3. Remember, if you have a position vector, you can easily transform the position vector to a coordinate point. If I have a coordinate point, I can easily transform the coordinate point to a position vector. We have been able to establish the simplicity in writing position vectors out of coordinate points and writing coordinate points out of position vectors, as we have in our final workings for the two examples last observed. So we see that our position vector transforms to the coordinate point of that particular position vector. So our B we got as 8, 11, and then our C we got as 6, 3. Here are some practice questions that you may want to look at on your own. X is the point 1, 9. The vector xy is given as 3, minus 5. Find the coordinates of y. If m is the point 4, 9, and n is the point 1, minus 3, find the vector mn. This concludes our lesson on vectors.